yet. He's here to go into the deeper science behind that first wave of snow we saw yesterday. And you were telling us that it's kind of been stumping you and the weather impact team, correct?
There's been a couple complexities. We had one with the first wave, and even as the second wave has been underway the last few hours, we've had a little bit sleet, just a tiny bit north compared to what a lot of miles and kind of what we were thinking. So I kind of want to talk about that. Let's actually focus in on the first wave that moved through late Friday and into early Saturday. This is a radar loop. This is not the current radar or anything like that, but this is the radar loop from Friday night, about 9 p.m. all the way to this morning, Saturday morning at 9 a.m. This was the first round, the first wave. You can kind of see those heavier blues, that moderate to heavy snow. If you kind of see as this loop plays over right now, as we continue into the overnight hours Friday into Saturday, notice those heavier blues are right along the I-40 corridor and southward with a little bit lighter snow in parts of northwest Arkansas. However, if you've looked at snowfall accumulations with that first wave, areas in the river valley only picked up about 3 to 5 inches of snow, which is decent. And then areas in northwest Arkansas picked up roughly about 3 to 4 inches. So despite the heavier snowfall rates here in the river valley, most areas actually picked up similar amounts. I was expecting, not just me, I think the whole weather team was expecting a little bit higher snowfall amounts. Now the big question is that we'll have to go back and look is that what were our snow to liquid ratios at this point? How much dry air do we have? We had it certainly at the onset of the event there for that first wave, but did it factor into that snow? Kind of some interesting complexities out there. Now, a lot of areas are dealing with some sleet out there right now. In fact, I kind of want to talk about snow to liquid ratios, but also sleet to liquid ratios. They're two different things, right? You often hear us talk about a snow to liquid ratio. So for every 10 inches of snow, if you were to melt that down, it would probably equal about 1 inch of liquid water equivalent. Sometimes it's 12 to 1 ratio. That's typically what we can expect for snow. Sleet's much different. In fact, the densities are also different there for sleet. It's much closer to about a 3 to 1 ratio. So for every 3 inches of sleet that you get, you melt it down, you get 1 inch of water. So there's definitely a lot more water content in sleet. So sleet has a different density. It's going to be compacting more. So that sleet that's falling in places, especially in the river valley, and especially if you're south of Fayetteville, areas are picking up some heavy sleet right now as I'm talking. That different density, that's going to compact some of the snow because that sleet's just a little bit heavier. So the snowfall tools that you saw that first wave, that's going to get shrunk down as that layer of sleet kind of falls on top of that. So it's going to be very hard to kind of get an accurate measurement for this whole winter storm. But overall, you get more sleet that equals less snow because sleet accumulates much less compared to snow due to those liquid ratios out there. So hopefully that made sense. Really the last thing I want to talk about is what's happening right now. You've probably maybe hear it on your rooftop of your window, those little ice pellets hitting. Lots of areas are seeing sleet right now. And why is that, you might be asking? Because it's so cold at the surface. Well, if you go several thousand feet up in the atmosphere, let's focus on this far right category here. We got warm air aloft in this little shallow layer. As that warm air aloft, about several thousand feet up, as that snowflake falls through that layer of warm air above the surface, it starts to melt. And we're talking about temperatures above freezing several thousand feet up. As that snowflake encounters that warm air, it starts to melt, then it encounters some more cold air. That refreezes over and it becomes an ice pelt, and that's exactly what we're seeing out there. And we'll kind of continue to see that there over the next few hours, depending on where you are. But of course, Scott's going to have that full look at that forecast in just a few minutes.